Today I'm going to introduce the first main technique of Calc 2 integration, which is integration by parts. So integration by parts is a nice technique which is used to into an integral when the integral is a product. Now we know that in integration there is no product rule. So if you do have a product, right? What do you mean by that? For example, if you do have an integral like this, right? So you can say that this is a product of x and e to the x, right? So one of the methods that you can try is this method called integration by parts. But first of all, not always, because if you take this one, then we do have a product here. Can you see that? X and e to the x squared. But this problem can be done by a simple substitution. So remember, always, no matter what situation you have, always try a u substitution first. And if that doesn't work, then you can try the other ones. So if you try the u substitution here, you can see that easily u equals x squared will work. Why will it work? Because if u equals x squared, then the derivative of that is x squared, the derivative is 2x, and that's pretty much the leftover part except for the constant, right? So that will work, and then you can do it yourself. I will not waste time doing that one. So just because there is a product, do not always try the heavy duty techniques, but try a u substitution before anything. All right. Now if you let's make a small change in this problem. Instead of having x times e to the x squared, let's put x times e to the x. Now can you use a u substitution? We have a product. Can we use a u substitution? Well, for example, if you call this this top part x to be u, right? Okay, then we have a problem. Why? Because the derivative of x is 1, right? So but the leftover part is also x, right? The derivative of u is 1, but the leftover part is x, not 1. So the derivative of the u will not match the leftover part, which is x. So for this one, a u substitution will not work. If the u substitution will not work, then we are going to try the integration by parts. When we do integration by parts, the first thing that we do is, see these two things, the product things, we identify them as two components. One of them will be comp 1 and the other one will be comp 2. Now comp 1 is always the one that is easier to differentiate, while at the same time comp 2 must be easy to integrate. So both must happen. So for example, just because the comp 1 is easy to differentiate, we should not select that as comp 1. We should also at the same time check comp 2 and see whether that is easy to integrate. Okay, so in this one, of course, is not a big deal, because here if you take x as comp 1, because that is the easiest to differentiate. Why? Because the derivative of x is 1, and then immediately check whether comp 2, which is e to the x, is easy to integrate. Well, it is easy to integrate, correct? Okay, because the integral of e to the x is e to the x. So in this case, it makes a lot of sense to take x as your comp 1 and e to the x as your comp 2. So we take comp 1 as x and comp 2 as e to the x. Okay. So now once we make that selection, we use the formula. So the integration by parts formula is like that. Which says the integral, I is the integral, I means the integral is equal to comp 1 integral of comp 2 minus comp 1 derivative, comp 1 prime, integral of comp 2, and then integrate again. So it's very important that the second piece, you have comp 1 derivative and then comp 2 integral, and then you integrate the whole thing again. Now let us plug in what we have. So comp 1 was x and comp 2 was e to the x. Correct. Okay, so let's put comp 1 as x. Okay, so x, just x. Okay, we don't do anything there. And integral of comp 2, which is what? Integral of comp 2 is e to the x minus the big integral sign, the derivative of comp 1. So that will be the derivative of comp 1, which is x. Okay, and the integral of comp 2, which is integral of e to the x. Now what do we have? We have I, which is the integral, is equal to x times, what's the integral of e to the x? Now I told you e to the x is very, very unique, because No matter whether you differentiate or integrate, you get the same thing, which is e to the x, right? It remains unchanged whether you differentiate or integrate. So the integral of e to the x is e to the x. So x, okay, so x here times integral of e to the x, which is what? Is e to the x, minus the big integral sign, the derivative of x. Now we know that the derivative of x is 1. Okay, so 1 times, once again, the integral of e to the x, right? Which is again e to the x. Now remember, there is a big integral sign still outside. Do not forget to do that. Alright, so then what do we had, right? Okay, so we have I is the answer, the final answer is equal to x times e to the x, and there's nothing to do here. Here you have to integrate again. So 1 times e to the x is still e to the x, and the integral of e to the x is e to the x, and of course plus a constant. So the answer is x times e to the x minus e to the x plus c. Once again, let me review what I did. So the first thing to do is, when you have a product, you select one of the components to be compound, the other to be comp2. Compound should be the easiest to differentiate, but always check whether comp2 is easy to integrate. Okay, so here we take compound as x, comp2 as e to the x, and then we use the integration by parts formula, which is compound integral of comp2 minus compound prime derivative of compound and integral of comp2. So we just plug in these numbers. So compound equals x, comp2 equals e to the x, right? So x here, integral of comp2, which is integral of e to the x, and then the big integral sign. Remember, you have two integrations. Second part, derivative, which is the compound derivative, which is the derivative of x, which is 1, and then the integral of comp2, which is e to the x. So then x times e to the x here, and here 1 times e to the x is e to the x. Once again you have to integrate that, right? So which is integral of e to the x, which is e to the x plus c. So let's do another quick example. Now if you use this one, x sine x, right? Notice that again we can try to select comp 1. Again we have product, and substitution will not work, because if you take u equals sine x, the derivative is cosine x. That is not the leftover part. Okay, so clearly it's integration by parts problem, right? And then we take, can I take x comp 1 as x? Well, x is very easy to differentiate, but wait a minute, is the other one easy to integrate? Yeah, sine x is pretty easy to integrate, because the integral of sine x is negative cosine x. So it's okay to take x as comp 1 and comp 2 as sine x. Okay, comp 1 is x, comp 2 as sine x. So now we use the formula comp 1 integral of comp 2 minus comp 1 prime comp 2. So comp 1 is x, right? Okay, integral of comp 2, which is integral of sine x, minus, remember you have to differentiate here, derivative of x, right? Comp 1, which is derivative of x, minus integral of comp 2, which is integral of sine x. So x times integral of sine x is negative cosine x, minus again a big integral sign, derivative of x is 1, and the integral of sine x is negative cosine. You've got to be careful of the negative signs, because we are now to do another integral here. Okay, so first of all, nothing to do here. So it's negative x times cosine x, very good, negative x times cosine x, plus, why do I put plus here? You got negative or a negative here, which is plus, right? And then we need to integrate cosine x. Okay, remember, and then of course negative x cosine x, nothing to do here, except the integral of cosine x is just sine x, and plus of course c. And then just a final answer. Now take this example. Now you have to be very careful here. If I take comp 1 as x, which is very tempting because x is easy to differentiate, ask yourself, is it okay to take comp 2 as natural log of x? Well, natural logs is not easy to integrate. We don't even know the integral of natural log so far. So comp 2, if you take as natural log of x, you are in trouble. Why? Because it is not easy to integrate. So that's a bad choice. Then what do you do in a situation like that? In a situation like that, you switch. So in a situation like that, you take x as your comp 2, not comp 1, and natural log of x as your comp 1. So x will actually be comp 2 and natural log of x will be comp 1. Is that okay? Yeah, natural log of x is easy to differentiate because the derivative is 1 over x. So you have to take it as comp 1, and x is easy to integrate too, not bad. Because why? The integral of x is x squared over 2. So you better be very careful when you have a natural log. The rule of the thumb is, when you have a natural log, you always try to take that as comp 1, not as comp 2. Alright my friends, so let's do a video homework. So the video homework is just like one of the examples that I did here to integrate x cosine x, and come to class ready and bring your answers written in a piece of paper with your name on it and showing all work, and it has been submitted at the beginning of the class. Alright, that's it for today. Have a great evening.